What's up everybody, Aditya Mahajan here and welcome back to yet another YouTube video. In today's video, we'll be solving another easy lead code problem, problem number 563, also called as binary tree tilt. It has also been asked in day 8 of December lead code challenge, so let's get started. Given the root of binary tree, return the sum of every tree node's tilt. The tilt of tree node is absolute difference between sum of all left subtree node values and all right subtree node values. If the node does not have left child, then the sum of left tree node values is treated as 0 and similar goes for right child. So what they are basically saying is, let us take a look at the first example to understand this. We need to return the sum of all the tilts of every node. So we need to calculate tilt of 1, calculate tilt of 2, calculate tilt of 3 and return sum of them. Now what is tilt? It is basically the sum of the absolute difference of sum of left and the right subtree values. Okay, so for leaf nodes it would be 0 because it does not have any children. So we have left subtree is 0 for 2 and right is also 0 because it does not have a right subtree. So it becomes 0 minus 0 modulo becomes 0. So for all the leaf nodes the tilt will become 0. Now if you take a look at 1, in this we have left subtree to be 2 and right subtree to be 3, and which is why we have 2 minus 3 left minus right subtree, and taking modulo gives us 1 and taking the sum of them will give us 1, so we return 1. Taking a look at the second example, what we have for the leaf nodes, that is 5, 3 and 7, they would be 0 because they do not have any children. For 2 and 9 it is very similar to the previous example, that is 3 minus 5, okay, for node 2, and for node 9 it is 0 minus 7 because it does not have any left child. And finally for the root node, what we have here is the left subtree values would be 2 plus 3 plus 5, which is like this, and the right subtree is 9 plus 7, and we take the absolute difference between them, which gets to be 6. Now the answer that we return is sum of all of them, all the tilts, and we return 15. Now let us look at how we can approach to the solution of the problem. Now, to understand the solution of the problem, I want you to think in terms of operations that we are performing because it is the prerequisite. So for calculating the tilt of every node, what we are basically doing is we are calculating the sum of left subtree, sum of right subtree, and then taking a subtraction and then taking the modulo. Okay, so the prerequisites or the things that we require are the sum of left subtree and sum of right subtree. If that is the thing that we have, then our work is done. Okay, so basically we are calculating the sum, subtracting and taking the modulo. Okay, so that is the first thing. Second thing, which approach should we go for traversal, that is top down or bottom up? Now while thinking a top down or bottom up, I want you to think in terms of operations that we just concluded in the first step. That is, our operation was to calculate the sum of all left subtree and all right subtree for every node, right? This thing is important that we are calculating this for every node so that we can do the less work if possible. Now for thinking for the approach bottom up or top down, if you think of a top down approach, that is we are firstly calculating tilt for 4. In that case we would require the sum of all the left and then the sum of right, which we do not have at this point. Okay, and let's say if we calculate this, then we go to node number 2. In that case we again need to calculate for its half part. Okay, that is we are doing repetitive work. But if we go bottom up approach, that is firstly calculating tilts for the leaf nodes and then going up, it would be a bit easier. How? If we calculate the leaf nodes, then they would be 0, of course. If we go one level up, then we just need to add the sum of left and right, which we already have, and just adding the value of ourselves and returning it to one above ancestor. Okay, because half of the work was already done. So in this way, if we go from bottom up, then our work would be a bit less. Now the third thing that we would be requiring is extracting the functionality. Okay, so the functionality is that we are the basic thing that prerequisite was calculating the sum. So we will basically create a cell function or something like that to extract the functionality, that is to calculate the sum of all its left subtree or all its right subtree. Okay, so that is the thing that we are doing. So try to think of in these three terms. So now let us try to code up the solution. So this is the code for the approach that we just discussed. Okay, so let us start with the main function, that is find tilt. As we talked about extraction, we are basically extracting the functionality, that is to calculate the sum of all its subtree into a function within a shell function. Okay, so the shell function that we'll be using is calc_sum, calculate sum for short, and we'll be passing root to it. One more thing that we'll be using in this is a global variable sum_tilt. You can also do it by passing this variable in all recursive function, but I prefer it taking a global variable. By this way, it becomes a bit easier. Okay, so this variable would be updated once we calculate tilt of any particular node, and we will keep on adding it to it, adding the tilt of every node to it. Now, what we are basically doing is, for any particular node, what we are saying is that if we are at any particular x node, then we are saying calculate sum, give me the left subtree sum value and also the right subtree sum value. Okay, so that is what we are doing. We'll come to the base condition in just a minute. Now, for any particular node, we are taking the left sum by doing a recursive call to the same function and giving it the left root left side value, and similarly calculating the right sum by giving it giving the recursive call to the right subtree. Okay, and we will get left and right sum. Now, there would be a case when we will reach the base condition, that is when we reach the leaf node. In that case, we will have the root to be null. Okay, so we just return 0 because it does not have any children. So for leaf nodes, we will have left sum and right sum to be 0. And for rest of the nodes, it would go on stacking up. Okay, so once we get the left and the right sum, what we are doing is we are updating the global variable sum tilt, because we have got the tilt of the current node, because we have left sum and right sum. We just subtract them and take an absolute value, and we are just updating the sum tilt. And now finally, to return to our parent node, what we are doing is we have the left sum, we have the right sum, and we are just appending ourselves, that is the current node that we are present on, to the left and the right sum, which gives us the complete subtree of that part. So that is what we are returning. And in this way, we get the solution. Now let us quickly try to run our code and see if it works. And yes, we are getting faster than 15%. I'm not sure why it is coming so slow, because it was the same solution that I gave earlier and it came a bit faster. It is because of the test cases that were taken. I think it generates test cases randomly. So this is the same solution that I got 12 millisecond time, which was faster than 100%. So that's all for this video. If you like the video, hit the thumbs up button. If you need more such LeetCode content, join the Discord server and subscribe to the channel. And yeah, I'll see you in the next one. Bye bye.